Look up at the night sky. Each star is a sun, a powerhouse of nuclear fusion governed by the laws of physics. Now, we stand at the edge of a new frontier, the quantum realm, where reality itself bends and breaks. This isn't science fiction. It's happening right now in labs across the globe. The quantum horizon is here. Are we ready to cross it? What is quantum magic? It starts with a simple idea, the qubit. In your computer, information is stored as bits, ones or zeros, on or off. But nature isn't binary. It's a world of maybes, of all at once. Enter the qubit, a quantum bit that can be on, off, or both at the same time, a phenomenon called superposition. Imagine a spinning coin. While in the air, it's not heads or tails, but both. Only when it lands, when we measure it, does it choose a side. A qubit exists in a cloud of potential, holding multiple values at once. This is the source of quantum power. But there's more. Entanglement. When two qubits are entangled, their fates are linked, no matter the distance. Measure one, and you instantly know the state of the other. This connection lets quantum computers create complex, interwoven states of information impossible for classical computers. Superposition and entanglement are the secret sauce. With just a few hundred entangled qubits, you can represent more possible states than atoms in the universe. It's not just about speed. It's about exploring a computational space of unimaginable vastness. Quantum computers can explore countless solutions at once. It's the universe's own parallel processing system, and we're finally learning to use it. The quantum dance of qubits is our ticket to solving the world's most complex challenges. The future of computation is here, and it's stranger and more powerful than we ever imagined. To grasp the quantum difference, picture a maze. A classical computer solves it by trying one path at a time, fast, but still sequential. If the maze is vast, even the fastest supercomputer could take longer than the age of the universe to find the exit. Quantum computers approach the maze differently. Thanks to superposition, they explore every path at once. Wrong paths cancel out, right paths reinforce. Quantum mechanics reveals the solution. It's like flooding the maze with water and seeing where it flows out. Quantum computers don't just offer speed, they offer a leap into new problem-solving territory. They're designed for massive complexity. Optimization, simulation, and problems that choke classical computers. For example, simulating how a protein folds or how a drug interacts with a cell. Problems with staggering variables. Classical computers struggle. Quantum computers are built for it. They speak the same quantum language as the molecules they simulate. Your laptop won't be replaced for everyday tasks, but the world's hardest problems are quantum in nature. We've been using sledgehammers to paint masterpieces. Now, we're building the fine brushes needed to paint the future. The quantum difference is about using the right tool for the job. Medicine will be one of the first fields transformed by quantum computing. The human body is a universe of complexity. Designing a new drug is like crafting a key for a microscopic lock. Today, drug discovery is slow, expensive, and based on trial and error. Quantum computers will simulate molecules with unprecedented accuracy. We'll build drugs atom by atom, testing millions of candidates virtually to find the perfect fit, fast and cheap. This means faster cures for diseases like Alzheimer's, cancer, and Parkinson's. It's not just about speed, it's about personalized medicine, tailored to your unique genetics. Imagine fighting viruses before they become pandemics, modeling new threats and designing vaccines in days. Quantum computing gives us a proactive defense for global health. It will revolutionize genomics, revealing patterns and risk factors invisible today. Preventative medicine could become reality, fixing genetic risks before disease strikes. The doctor of the future may prescribe an algorithm before a pill. The quantum revolution will ripple through every corner of society, including finance and climate science. Financial markets are tangled webs of risk and data, too complex for today's models. Quantum computers will bring clarity, solving optimization problems on a scale never seen before. Imagine instantly finding the most efficient routes for thousands of trucks, or building perfectly balanced investment portfolios. Fraud detection will become nearly unbreakable. Climate change is our greatest challenge, and quantum computers can help. They'll simulate chemical reactions, invent new materials, and design better batteries and solar panels. We'll discover catalysts for cheap carbon capture and invent fertilizers with a tiny carbon footprint. Quantum computing lets us tackle climate change at the molecular level. It's a tool for a sustainable future, built on a deeper understanding of nature. The solutions we need are quantum in nature and now within reach. The future of finance and the planet depends on it. With great power comes great peril. Quantum computers threaten our digital world because they can break the encryption that protects everything from bank accounts to state secrets. Modern security relies on the difficulty of factoring large numbers, a task quantum computers can solve with shocking speed. When a large-scale quantum computer arrives, today's encryption will be obsolete. Every encrypted email, transaction, and secret could be retroactively decrypted. Adversaries are already harvesting encrypted data, waiting for the quantum key to unlock it. The consequences? A cryptographic apocalypse, banking collapse, compromised infrastructure, lost trust. We're in a race to rebuild our digital defenses before our walls turn to dust. The threat is silent, invisible, and growing closer every day. The quantum threat is real and urgent. Our digital civilization depends on how we respond. Are we doomed to digital anarchy? No. Mathematicians and cryptographers are building our defense post-quantum cryptography, or PQC. PQC isn't quantum cryptography. It's a new generation of classical algorithms, secure against both classical and quantum attacks. The goal: find mathematical problems hard for all computers, quantum or not. Quantum computers aren't all powerful, they're just good at certain problems. Cryptographers are exploring lattice-based, code-based, and multivariate cryptography, fields believed to be quantum-resistant. The U.S. National Institute of Standards and Technology has led a global competition to standardize the best PQC algorithms. After years of testing, a handful of winners will become the new gold standard for security. Now comes the hard part: implementation. Upgrading every piece of software, server, and device is a monumental task. It's not a simple patch, it's a fundamental overhaul. Governments, corporations, and developers must coordinate to secure our digital future. The tools are here. Now we must use them. The transition to quantum-safe security can't wait. Experts believe a quantum computer capable of breaking today's encryption could arrive within 10 to 15 years, maybe sooner. Upgrading global systems takes time. We're already living on borrowed time. The window to prepare is closing fast. This is like Y2K, but infinitely more complex and dangerous. We can't wait for disaster to strike. The transition to post-quantum cryptography must begin now. Governments must set standards and deadlines, especially for critical infrastructure. Corporations need to audit vulnerabilities and plan upgrades. It's a hidden, technical problem with real-world consequences for economic stability and national security. The next decade is a race between quantum builders and quantum defenders. The outcome will define the dawn of the quantum age. The quantum realm was once a locked door, but we've picked the lock. We're stepping through, and the view is awe-inspiring. Quantum computing promises cures for disease, solutions for climate change, and a new dimension of knowledge. This power must be wielded with wisdom and foresight. The quantum threat is real, but it's a call to action, not fear. By embracing post-quantum cryptography and acting now, we can secure our digital world. The journey into the quantum age is humanity's next great adventure. The challenges are great, but our ingenuity is greater. The next 10 years will test our ability to collaborate, adapt, and build a more secure, equitable future. This is our moment to be good ancestors. Let's look to the quantum horizon with wonder and responsibility. We have the privilege and duty to steer this revolution for the betterment of all. The story is just beginning.